Alright, subscribers, welcome back to another episode of Science with Surbeck. Today what we're going to be talking about is mixtures of matters, or section 3.3. And in this section there are a few objectives I would like you to be able to meet. Objective number 1, contrast mixtures and substances. Objective number 2, classify mixtures as homogeneous or heterogeneous. And objective number 3, list and describe several techniques used to separate mixtures. So we start out here with the definition of mixture. A mixture is defined as a combination of two or more pure substances in which each pure substance retains its individual chemical properties. Now, within mixtures, they're going to have variable compositions, and they can have infinite combinations. It should also be noted that most everyday matter occurs as mixtures. And this is because substances tend to naturally mix. And in the real world, it's difficult to keep substances pure. Now, the best way to understand mixtures is through some examples. So our first example is salt water. And salt water is a colorless liquid or colorless mixture that appears the same as pure water. Now, salt water can be brought or taken into its individual components by separating off the water via boiling it. It boils away or evaporates the water and leaves behind the salt. Now, another good example is sandy water. Keep in mind that sand is a grainy substance that does not dissolve in water. Now, just like any mixture, sandy water can be separated, but it needs to be separated through filtration. Now, with mixtures, we can actually categorize it into two main subcategories. The first of which is what we refer to as a heterogeneous mixture. Now, a heterogeneous mixture is defined as a mixture that does not blend smoothly throughout and in which the individual substance remain distinct. Now, a way to summarize a heterogeneous mixture is this: it is not uniform throughout. Now, again, the best way to see heterogeneous mixtures is through some examples. Our first example would be a sand and water mixture. And to show you that it's not uniform throughout, we have the following examples. If we take a drop from the top of the mixture, it would be mostly water. And if we took a drop from the bottom of the mixture, it would mainly contain the sand. Another good example would be fresh orange juice that contains pulp. Now, in most cases here with orange juice with pulp, the pulp itself is going to float to the top of the mixture. Now, the juice component of the mixture would be below the pulp. Now, the other category of mixtures we have are what we have as homogeneous mixtures. Now, homogeneous mixtures are defined as mixtures that has constant composition throughout. Now, what this means in a homogeneous mixture is that it only contains a single phase of matter throughout the entire mixture. Now, homogeneous mixtures also contain solutions, or something we refer to them as solutions. Now, just because something is a solution or a homogeneous mixture doesn't mean it can't be any state of matter. So homogeneous mixtures can be solid, liquids, or gases. Now, again, the best way to think about homogeneous mixtures is through some examples. Now, our first example would be soda. In a can of soda or a soda that you drink, every drop of the mixture contains the same relative amounts of sugars, carbonation, and water. Now, another example of a homogeneous mixture is what we call an alloy. Now, alloys are specifically defined as homogeneous mixtures of metals. And a specific example here of a metal alloy would be the US Mint's golden dollar coin. This coin is a solid solution. And the alloy itself is composed of 77% copper, 12% zinc, 7% manganese, and 4% nickel. All right, so as mentioned before, we can talk about how we can separate mixtures. So we get into the real basics of separating mixtures here. And like I said, there's multiple ways to separate a mixture. And depending on the type of mixture that you have, will determine how you can separate that particular mixture. So what we have to remember is this. Most matter is going to naturally exist as a mixture. And what we have to remember as a mixture is that substances are physically combined. And so that physically combined is a key word, and what that does is if we take those differences among physical properties, we can use those differences to separate mixtures into their individual substances. So again, the key takeaway here is that we're separating solutions based on their physical properties. So that means we're not going to affect any chemical composition. We're not going to have any changes occur to each of those substances involved in a mixture. Physical separation means we do not alter those particular chemicals or those particular changes of matter. Now, as I mentioned before, we have several separation techniques, and we really only scratch the surface introducing what type of separations we have. And so the first separation technique that I want to talk about is called filtration. Now, filtration is a technique that uses a porous barrier to separate a solid from a liquid in a heterogeneous mixture. Now, what filtration does is it allows the liquid to pass through the porous barrier, and it's going to leave the solids trapped in that porous barrier. Now, I'm not going to write this down, but a great use of filtration would be that of separating out a sand and water mixture. Again, the water would be allowed to go through that porous barrier, and the sand would be left on top. Now, typically we would use a simple substance called a filter paper to accomplish that filtration. Now, another technique here that I want to discuss on this page is distillation. Now, distillation is a separation technique that is based on the differences in the boiling points of substances. Distillation specifically separates those homogeneous mixtures, and how it does it is it heats the mixture until the lowest boiling point boils to a vapor. So once that liquid is boiled to a vapor, the vapor is condensed into a liquid and can be collected. Now, with this distillation technique, you can separate substances that have different boiling points, even if those boiling points only vary by a few degrees. And it's actually pretty cool to go through an experiment that deals with distillation. You'll actually see the entire mixture boil, and then you'll start to see the vapor of one of the pure substances condense in your condensation tube, and you'll start to see tiny drops appear. And then it'll go a period where there is no liquid that is condensing, and then once more you'll start to see drops appear, or drops condense through your condenser tube, and that is that next pure substance or that next liquid that is being boiled off at a specific temperature. And you can use a thermometer to show or identify where that next boiling point will be, and that is used to help identify some unknown substances. Again, a benefit about doing distillation. The only downside is you have to have a homogeneous mixture. Typically, we use a homogeneous liquid solution. All right, 3 more techniques that I want to talk about here before we leave. And that first technique is known as crystallization. And crystallization is a separation technique that results in the formation of pure solid particles from a solution containing the dissolved substances. And so crystallization is unique because it's going to occur in a saturated solution where a tiny amount of pure substance added can often cause the dissolved substance to come out of a solution. So again, that's like adding tea or adding sugar to tea. You reach that max amount, one little bit more drop of sugar will actually just make it fall to the bottom of the solution. That's what I'm talking about here with a saturated solution. Now, what you can think about here is that the crystallization here, when we have this saturated solution, what happens is that the pure substance are going to collect as crystals on an available surface. Typically, we see this available surface as the bottom of a beaker or something similar to that in nature. Now, another separation technique that we have is sublimation. Now, sublimation is the process of a solid changing directly into a gas. And sublimation can be used to separate mixtures of solids where one sublimates and the other does not. Now, I will say that sublimation is a very rare technique. I've never used it in my career, but nonetheless, it is a type of separation technique. Now, our 5th and final separation technique is known as chromatography. And chromatography is a separation technique that is going to separate components of a mixture on the basis of the tendency of each substance to travel across the surface of another material. Now, this chromatography is going to occur because of the various components of a mixture are going to move at different rates. And we haven't discussed this, but I'm going to put this in parentheses here. It's based on the polarity of molecules. Again, that says occurs because of the various components of a mixture move at different rates. And again, I put in parentheses polarity, not like it means much to you right now, it will in the future, but that is the reason we are able to have that chromatography separation technique. All right, so this concludes section 3.3. I hope you have enjoyed this episode. And as always, if you haven't done so already, make sure you subscribe.